is the key to your review. All right, so the graph of function f is shown above. Which of the following statements about f is correct? Just asking me about the function, okay? But, so here, f, like what is happening with f? Well, as x gets bigger, the y values are decreasing, so f is decreasing. I can eliminate those. But then it talks about the rate. So once I start talking about the rate, I need my fun chart. Okay, so f is decreasing. I know that, so it's C or D. And is the rate increasing or decreasing? Well, that depends on whether the function is concave up or down. This is concave up, therefore the rate is increasing. So it is decreasing at an increasing rate. So here we go. G, which of the following statements about G is correct? Okay, so this talks just about the function G. So I don't need my fun chart because I'm just talking about the function. The function itself is increasing, so I can eliminate C and D. Then, and it says the graph of G, still not talking about the rate, still don't need the fun chart, concave up. So this is up, down, so my answer is A. Okay, logarithmic function is defined by h of x. Excuse me. Which of the following statements about h is correct? Okay, so I need a little graph here. I know that just this part is going to look like this. The 2 itself would be a vertical dilation and stretch it, which doesn't really change much the way it looks since I don't have a scale. But this negative reflects it in the x-axis, so it ends up looking like that. So this is the one I'm looking at. The function itself is decreasing, so the function is decreasing, so I can eliminate A and B, and it is concave up, which is C. Okay, here's K, which of the following is correct? So we start off talking about rate of change, so I know I need my fun chart. Okay, so rate of change, I want to know if it's positive or negative. So if my rate of change, when I'm looking at whether or not it's positive or negative, I need to know if my function is increasing or decreasing. This function is clearly decreasing, which means the rate of change is negative. So I can eliminate A and B. Then to know if the rate of change is increasing or decreasing, I look at the concavity. This one is concave up, so the rate of change is increasing. So negative and increasing. Here we go, which could be an equation for f. Okay, so we don't have a scale here, so the 3's, they're there, but whatever. And it's natural logs, no big deal. Here's what we definitely should know. If I have an exponential, that's what the basic parent function looks like. So this is my exponential, this is my log, okay? So I know that it does not look like this, boom. If I reflect this in x, then it looks like this. It also doesn't look like that, so it's definitely not an exponential. It looks exactly like that, so that's a log, but I just wanted to show you why it wasn't those and why we haven't reflected. Okay, logarithmic function. Which of the following pairs of statements correctly describes the end behavior? So again, I think having a little sketch drawn is very helpful. Excuse me. And so here I have -3 log base 4 of x. So the log base 4, it is what it is. But this part right here, just the log base 4 of x, looks like that. The 3, again, stretches it, but doesn't really change, when I don't have a scale. But that negative reflects it in the x-axis and would make it look like that. So this is what I'm looking at. Remember that you have an asymptote here. So as x approaches, well, x doesn't get to approach a negative infinity. So C and D don't even make any sense. So I know I'm approaching 0 from the right. As I approach 0 from the right, going this way, the y value is approaching infinity. So I think I like B, but let's do the next part here. As x approaches infinity, y is approaching negative infinity. So I definitely like B. All right, which of the following is the domain of function h? Okie dokie. So here is what we're going to start off with. We're going to start off with just natural log of x, okay? Like I have no transformations. It looks like that, okay? And I have an asymptote here. The only thing that changes the domain, so let's think about what's happening here. This stretches it, doesn't change my domain. This moves it down, doesn't change my domain. This is what's going to change my domain. So, goodness, that's bad. So I have that x minus 3. X is a liar. That means I go to the right 3. And so my asymptote that was here is now here. And my graph looks like this and goes through 4. So my domain starts at 3 and goes to infinity, and I don't get to include it. Okay. Okay, graph of f. Okay, we're talking about just the function. So the function is clearly decreasing, so I can eliminate a and b. Then we talk about the rate of change, so we need our fun chart. Okay, and I want to know if the rate of change is increasing or decreasing. So if I'm looking at increasing or decreasing, I'm looking at concavity. This is concave down. Concave down means my rate of change is decreasing. So the function is decreasing, and so is the rate of change. All right, which of the following statements about P is correct? Okay, so my function basically looks like this. Now, if the base was 1/2, it would change my graph, but all that does is squish it. It still just looks like that. And so the function itself is increasing, right? So I can eliminate C and D, and it is concave down. So that's B. All right, values of function k are shown in the table above. Its selected values of x. Determine if the function k could be linear, exponential, or logarithmic, and explain your reasoning. Okay, so I just realized on my key that I had out for y'all to look at, had last year's words, remember, before we got more information. So we want to be careful with this. When I look at k of x, the right-hand side here, I can see that I am, each time I am adding a -2. Here, each time I am multiplying by 3. Okay, so since I have equal length output values and my input values are being multiplied, that means it would be logarithmic. So my answer is going to be logarithmic, and here's my reason. Input values are multiplied by 3, and we have equal length output value intervals. Okay, equal length output value intervals. Remember, we want to talk about inputs and outputs, not x's and y's so much. All right, number 11. Here is my equation. Which of the following could be the graph? So without looking at the graphs, I'm just going to make my own graph. I know that the natural log of x part looks like this. You should too, because I've only made you draw it 5 million times. That 3 stretches it, but don't really change it. So my answer is A. Okay, so I've got this function. Looks like this. The 2 stretches it, but doesn't really change anything else. So as I move to the left, x does not get to head to negative infinity because it can't get past here. So I can eliminate those. So I know x is approaching 0 from the right. And then as it approaches 0 from the right, the y values are approaching negative infinity. So I think I like A. And as x approaches infinity, y is also approaching infinity. So I do like A. All right, here we go. Here's my graph. Guess what? It looks just like the last one, even though the equation looks different, right? But that's just for this part, okay? It's the log. Now the 1/3 squishes it, but no real big change when I don't have a scale. This negative, though, he's important. He reflects this, and I'm not looking at that one, I'm looking at this one. Once again, x cannot head to negative infinity. It gets stopped by 0, so it's A or B. And as x approaches 0 from the right, y is approaching infinity, so I think I like B. And as x approaches infinity, y approaches negative infinity, so I definitely like B. All right, which of the following statements about g is correct? Right, so I want to know if the function is increasing or decreasing, concave up or concave down, so I need myself a little picture. The log looks like this. That 6 stretches it, that's it. So this function is definitely increasing, so I can eliminate C and D, and it is concave down, which is B. All right, so again, I need a little graph. The natural log part makes it look like this. The 5, whatever. But that negative reflects it in the x-axis. This is what I'm looking at here. So that function is definitely decreasing. So I can eliminate A and B. But then we're talking about the rate. So we need our good old fun chart. And if I want to know if the rate is increasing or decreasing, I'll look at the concavity. This is concave up, and concave up means my rate is increasing. All right, which of the following statements about G is correct? So once again, I need a picture. Now this is log base 5. It's not just the log, it's not a natural log, but it doesn't matter. Your parent function looks the same. The 3 stretches it, no big deal. Okay, so now we look over here. G, the function itself, is definitely increasing. So C and D. And then we're talking about the rate. So I need my good old fun chart again. Okay, if I want to know if my rate is increasing or decreasing, I look at the concavity. This is definitely concave down, which means my rate is decreasing. All right, natural log of x, graph looks like this. The 1/2, it squishes it, no big deal. Looking at the function itself is increasing, so I can eliminate A and B. And then we're talking about the rate of change, so I need my fun chart. And if I want to know if the rate is increasing or decreasing, I'm looking at concavity. We're concave down, so the rate is decreasing. The answer is D. All right, H is defined by this, so I need a picture. The log base 2 looks like this. That negative, though, reflects it, and it looks like this. All right, the function H. The function H is decreasing, so I can eliminate C and D. I know this seems very repetitive, but I think that this is what some of you need, because this whole rate of change and function thing was really hard on your brains at the beginning of the year, and it's been a minute, so we need to make sure we can wrap our minds around this. Okay, then we're talking about rate of change, so I need my fun chart. And let's see, increasing, decreasing is concavity. We're concave up, so my rate is increasing. Answer is A. All right, 32. Log looks like this. The 3 doesn't really do much. Now, this is talking about the rate of change overall. It's not asking about the function at all. So, fun chart. The more you write it, the more likely you'll get it right when you need it. Plus, I feel like if you write it over and over again, then you can actually write on it. So like if I want to know if the rate of change is positive or negative, I'm looking at whether the function's increasing or decreasing. Function's increasing, which means the rate of change is positive. So I can eliminate C and D. Then I want to know if the rate of change is increasing or decreasing. Function is concave down, so the rate is decreasing. So you can see that the rate is positive and decreasing. The function is concave down and increasing. Alrighty. G, so here's natural log. The 2/3 is what it is, but that negative gives me this. We're talking about rate of change again, so fun chart. And if I want to know if it's positive or negative first, so I'm looking increasing or decreasing. This is decreasing, so the rate of change is negative. Eliminate A and B. Excuse me. And this is concave up, therefore the rate is increasing. So the rate of change is negative and increasing, which is C. All right, 14. Select the values of F, which of the following claim. Okay, so I'm going to read through my answer choices to see even where I'm trying to go. Basically, it's asking me if it's logarithmic or exponential. Okay, so when I look here, looks like here I am adding 3 each time. Looks like here I am multiplying by 2. Okay, so since I'm adding 3 and multiplying by 2, when that happens, when my outputs are being multiplied, that is exponential. So I know I can eliminate A and B. And then best model by an exponential because the outputs over consecutive equal length input value intervals are proportional. Okay, so both of these talks about outputs and inputs, right? Proportional. Now that's a different form of the word of how we've been describing it, but you can see it multiple ways, okay? Here, these are equal length intervals. I have equal length input value intervals. So even if the proportional thing makes you, messes you up, I have equal length input value intervals. This says equal length output value intervals, not what I have. Okay, so the outputs over equal length input value intervals, that's what I have, are proportional. And they're proportional because they're being multiplied by the same number. My answer is C. All right. Which of the following claims? So best, same kind of answer. So here, I'm multiplying by 1/3 each time. And here, I'm adding 2 each time. Okay, so when my inputs are being multiplied and my outputs are equal length, that makes it logarithmic. So I can eliminate C and D. Now again, you can find the words in here that you can make sense of. H is best modeled by a logarithmic function because the outputs over, then it says consecutive equal length input value intervals. Is that what I have? I do not have consecutive equal length input value intervals. This says a logarithmic function because the inputs over consecutive equal length output value intervals. You want to be careful just taking some words out of context because of the way sentences can be written backwards. So it's talking about the inputs over consecutive equal length output value. That's what I have. These are equal length output value intervals. And my inputs are being multiplied. That makes them proportional. Okay. So now we have this graph for some inverses. The graph of, we have a piecewise linear function, 3 linear segments, values of G and H are given in this table. F inverse, H inverse represent the inverse. Okay, so H inverse of 2. So if I wanted H of 2, I would go to 2, and this would be H of 2. But I want H inverse, so I go backwards. I find H of 2, and I go backwards, and that's -1. So H inverse of 2 equals, oh goodness gracious, equals -1. All right, find the value of F inverse of 2. So here's F. Now again, F of 2, I would go here and here, but I want F inverse of 2, which means I find the Y value of 2 and answer with the X value, which is 0. So F inverse of 2 equals 0. To give you an example of what the answer would look like if it was not defined, is if I said, like, what is H inverse of 1? So H of 1 would be 0, but H inverse of 1, there's not a 1 here, so it's not defined. I couldn't give you the answer. Doesn't mean it doesn't exist at all, just they didn't give me enough information for it. Okay, so then I have find the value of L of 2. Okay, so this tells me, come down here a little bit. F inverse of H of X, which I would prefer to write that way anyway, that's equal to L of X, right? So so that means that L of 2 is equal to F inverse of H of 2. Okay, just substituting it in straight into there. So the first thing I want to find is H of 2. H of 2 is -2, which means now I need F inverse of -2. So I go and make sure I find F. Here's F. F of -2 is 1, but I want F inverse, so negative. Find the Y value. So F inverse of -2 is -4. All right. So we're going to find the inverse, okay? And this is old business, so I know y'all should be able to do this. I'm going to change my F of X to Y. Then I'm going to switch X and Y and get X equals 4Y minus 7. Then I'm going to solve for Y. So X plus 7 equals 4Y. So X plus 7 over 4 equals Y. And it's totally fine to leave it like that. You don't need to get fancy. And so then I write it as F inverse of X equals X plus 7 over 4. Not only do you need to not get fancy, some of y'all try and get fancy and simplify that and do weird things. Don't do weird things. Okay. So I'm going to change this to Y. So that's going to give me X equals 2Y plus 7 over 3Y minus 4. Okay, 7 looks weird. And so I'm going to start by getting rid of my denominator. I'll multiply both sides. So X times 3Y minus 4 equals 2Y plus 7. Then I'm going to distribute. 3xy minus 4x equals 2y plus 7. My goal is to solve for y. So I need to get all of my y's together. So I'll move up here. I'll put all my y's on the left. So 3xy minus 2y equals 7 plus 4x. Now I cannot combine the two terms on the left because one of them has an x and one of them doesn't, but I can factor out a y. So y times 3x minus 2 equals 7 plus 4x. So y is equal to 7 plus 4x over 3x minus 2. That means that g inverse of x is equal to 7 plus 4x over 3x minus 2. I would imagine some of you might have 4x plus 7. Totally fine. Doesn't matter. Okay. Number 3. Make that into y. So if you totally just copied down what I did because you had no idea what to do, make sure you pause this and actually try and do this one on your own. So x is equal to y minus 2 over 6y plus 4. X times 6y plus 4 equals y minus 2. Distribute 6xy plus 4x equals y minus 2. All right, now again, I'm going to get all my y's together. So 6xy minus y equals negative 2 minus 4x. Factor out my y. Going to give me 6x minus 1 equals negative 2 minus 4x. So y equals negative 2 minus 4x over 6x minus 1. So that means that h inverse, because I'm not calling it f because we're not going to be a Melissa, negative 2 minus 4x over 6x minus 1. Okie dokie. End behavior. So I'm going to draw myself a picture. The natural log looks like this. That negative makes it look like this. Mark that out. Now, if you noticed on my key, if you saw my paper key, I had to mark out part of the answer because clearly I did not read the directions when I did it the first time. It says determine the end behavior of L as x increases without bound. So that means that's the limit as x approaches infinity of L of x. So as x increases without bound, y decreases without bound. So my answer is negative infinity. All right, let f be a decreasing function defined for x is greater than 0, greater than or equal to 0. We have values. It's selected values of x, which means there's other stuff going on. And then it gives you, so this is f, this is g, two different things, okay? So h is defined as g of f of x. So I'm just going to write that down. So h, oh well, it's basically written here, but I want to find the value of h of 0. So h of 0 is equal to g of f of 0. Okay, so f of 0 is 8. So this gives me g of 8. So g of 8, once I substitute that in there, that is equal to log base 2 of x. Oh, duh, of 8, because that's my x value of 8. Now, I want to figure out what that is, okay? I've already used an x and stuff in here, but if I want to figure out what this is, I can say log base 2 of 8. I mean, I could set it equal to x. I could set it equal to whatever. I'm going to use z just so it's different. And then I'm going to rewrite it as an exponential. So 2 to the z power equals 8. And 2 to the third power would equal 8. So this equals 3. Okay. All right, so then I want the value of f inverse of 4. So remember, f of 4 is 1/2. F inverse of 4 would give me 1. So f inverse of 4 equals 1. Good. All right, determine the end behavior of g. So we want to make sure we're looking at the right thing. As x increases without bound. So I go back up here and I look at g. G is just a basic log. So my picture looks like this. Apparently I did the same thing on the key to this one, and I didn't mark it out. It only says increases without bound. So this is the limit as x approaches infinity of g of x. And that equals, well, as x increases without bound, y also increases without bound, and we're going to infinity. All right, so then it tells me to use the table of values, so it even gives it away, so it's hard not to look at the right thing for f. To determine if f is best modeled by linear, quadratic, exponential, or logarithmic. So I'm going to go back up here. All right, so my x values, I am adding 1 each time. My y values being multiplied by 1/2. Okay, now here's what I want you to pay attention to on this. This part only says determine if it's mess ball. It does not say that we have to explain it here. So if you notice also on my paper key, I had to draw an arrow because I did way too much here. But the answer here, I guess we need to go back up there and look at that again. I have equal length input value intervals and my outputs are being multiplied. That makes it exponential. So I can just say F is best modeled by an exponential. Because the second part says, give a reason for your answer based on the relationship between the change in the output values and the change in the input values. Okay, so then we can say that F has equal length input value intervals and output values are multiplied by 1/2. Okay. Alrighty. So then the little half sheet that I gave out the other day, because I left this part off originally, this is just rewriting, which as much of rewriting as we've done the last few days doing the new stuff, I think you got this. You just want to try now not do too much, because like on 1, 2, and 3, we're not solving. You're literally just rewriting it. So the base of the log is 2. So this would be 2 to the 6th power equals 64. Now here, the base is 4. 4 to the negative 3rd power equals 1 over 64. Keep going around in a circle. Then 25 to the 3/2 power equals 125. Okay. Now we're going to go the other way and write our exponentials as the logs. So the base here is 10. So we can write log base 10. Remember, you don't have to have that, but sometimes you might see that. The base is 10. Log base 10 of 1,000 equals 3. Round in a circle. Base of the exponential is 16. So this is going to be log base 16 of 1024 equals 5/2. Okay, the base is 10 again, so this time I'm just going to write log of 1 over 100 equals -2. Okay, I'm going to give you a bonus one on this. What if I had e to the 5th equals y? If I rewrite that as a log, that log base e, that becomes natural log of y equals 5. Okay, so just remember your natural logs and your e's there. Okie dokie. Now this one, we are actually finding the value. So when you need to find a value, I would set this equal to x and then rewrite it. So I'm going to write 5 to the x power equals 625. So I'm going to get common bases here. 5 to the x equals 5 to the something, right? And so I know 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625. Also, I want you to think about this. If you actually know your perfect squares, which you should, if I'm going to multiply, if I'm going to get to 625, so I know 5 times 5, that's 25. Well, I know that 25 times 25 is 625. So this would also have to give me 5 and 5. So that's 4 of them right there. So this equals 4. All right, so if I set this equal to x, this base is 10. So 10 to the x power equals 100,000. One more 0. Okay, so let's count our tens. So we're going to get 10 to the x equals 10 to some power for the 100,000. So I have 10, 100, 1,000, 10,000, 100,000. That's 5 of them as well. Okay, so x equals 5. All right, set this equal to x. So I'm going to get 27 to the x power equals 81. So I need to go to common base. Like on the other two, 5 and 10, clearly that was going to be my common base. 27, not my common base. But, and I know 9 times 9 is 81, but 9, that's not going to help me. I can't get a base 9 on 27 easily. So I can use 3. I know 3 cubed is 27. So 3 to the 3x power. And then this would be 3 to the 4th power. So I get 3x equals 4. So x equals 4/3. And there you go.